Welcome back to General Chemistry on Catalyst University. My name is Kevin Tokoph. Please make sure to like this video and subscribe to my channel for future videos and notifications. In this video, I'm going to be showing you how to draw Lewis structures, and over the course of the next few videos, we're going to see several examples of that. So, in this example, we're going to have the compound BF3, and we want to draw its Lewis structure, which I already have down here, but I'm going to go through the explanation of how we actually determine that. And I've got several steps up here, and while there might be some deviation from this in some few problems that you might have, this is a very general look at how you do most of them. All right, so the first step we're going to do is count the total number of valence electrons. I'll show you how to do that. Once you have a number for the total valence electrons, you're then going to determine what the central atom is. Okay? Generally, the central atom is going to be the one that's the minority, where there's the least of them. So notice we have 1 boron and 3 fluorines. The boron is probably going to be the central atom. Once we determine that, we'll draw all the peripheral atoms around the central atom being connected by single bonds, at least initially. And those single bonds, remember, they're bonds, so they're bonding electrons. And then after that, we're going to add lone pairs, which are our non-bonding electrons, onto all the peripheral atoms, making sure we don't exceed the octet on any particular atom. All right. So we've got this compound BF3. Let's first determine the total number of valence electrons. So the way we do that is I kind of set it up as a math problem, and you don't have to do this forever. Once you get the hang of it, you can kind of skip this step. But I've got 1 boron, 1B, and I've got 3 fluorines. So I'm going to set it up like a math problem, and I need to determine how many valence electrons there are per each of these atoms, boron and fluorine. The way I'm going to do that is I'm going to look at the periodic table. So if you look at the column number, that's going to tell you how many valence electrons that particular element has. For example, this is column 1 over here on the far left, starting with hydrogen. This column is column 1, so these have 1 valence electron. Over here, starting with beryllium going down, this is column 2. These elements, such as beryllium, magnesium, they have 2 valence electrons. When determining this, we always skip the transition metals and go to the column that says boron. This is column 3. These have 3 valence electrons. The column with 4, all of these have 4 valence electrons, and so forth. 5 valence electrons, 6 valence electrons, 7, and 8. And so my first element is boron. So boron is in column 3, and so therefore this would have 3 valence electrons. So I put a 3 valence electron here. Then for fluorine, going back here, fluorine is in group 7. So therefore, fluorine atoms each have 7 valence electrons. Okay, so 7 valence electrons per fluorine, and then I pretty much multiply and add this up. 1 times 3 is 3, plus 3 times 7 is 21, so it's 3 valence electrons from the boron, 21 valence electrons from the fluorine, giving me a total of 24. Okay, again, when you get the hang of this, you may be able to skip a little bit of this, but you'll first definitely need to count the total numbers of valence electrons. Now, the next step, I said determine the central atom, and usually this is the minority atom. So in a lot of cases, when you get these compounds on an exam or something, there's going to be one atom that there's a lot of them, sometimes 3, 4, 5, or even 6, and then a lot of times there's going to be an atom where there's only one of them. The one where there's one of them, or the least of them, that's going to be your central atom. So notice down here I've drawn boron as being the central atom. Then what I'm going to do is I'm going to draw the peripheral atoms around the central atom bound by single bonds, which are going to be bonding electrons. So I've got 3 fluorine atoms. I would need to arrange them in a way something like this, where all the fluorines are positioned around the central atom. And notice in this case they're all connected by single bonds. Now, they're all connected by single bonds, and each bond is 2 electrons, because remember, these are covalent bonds, and so 1 electron is being donated by each of these elements and being shared. So there's 2 electrons per bond, and there's 3 bonds. So having said that, I've already used up 6 electrons. I used up 6, okay? So bear that in mind. Now, I need to add the non-bonding electrons around each of the peripheral atoms, because that's my last step. So add the lone pairs or non-bonding electrons up to the total that we've calculated, 24, so that I don't exceed the octet on any of those atoms. Okay? And one thing, so let's look at the top fluorine here. I'm going to add 1, 2, 3, 4, 5, 6. So I'm going to add 6 non-bonding electrons, that's 3 lone pairs, and you ask yourself, why don't we add any more? The reason is because it would violate the octet for this fluorine atom. So remember that elements in the second period, such as boron, carbon, nitrogen, oxygen, and fluorine, can have a maximum of 8 electrons. Okay? So, that being said, there's 6 non-bonding electrons, and we have to count the 2 from this bond. Okay? That's 6 plus 2, which is 8, so I've already hit the octet for this fluorine atom, therefore I can add no more non-bonding electrons to the fluorine. And since all these fluorines are the same, I'm going to be adding 3 lone pairs or 6 non-bonding electrons to each of them, okay? And keep in mind that we have 2 electrons per each of these 3 bonds. Those bonds gave us 6 electrons, so let's count the number of lone pairs that we're going to add, or count the number of non-bonding electrons, I should say. So we had 6 already, 7, 8, 9, 10, 11, 12, okay? 13, 14, 15, 16, 17, 18. And then 19, 20, 21, 22, 23, 24. And that's the total number of valence electrons. So in this case, we're actually done. This is the Lewis structure of boron trifluoride, or BF3. And again, I've removed all the electron numberings right here. But basically what I did is once I calculated how many electrons were simply due to the bonds, then I just add the lone pairs around each of the peripheral atoms until I hit this number of total valence electrons. And so adding these up did give me 24, so this is my final structure and final answer. So none of these atoms here have their octets violated. Okay. One thing I will tell you though is this boron is less than its octet. One thing that's important to remember about boron in particular, and also aluminum, really these 2 atoms right here, boron and aluminum, while they can't have more than an octet, they can have less, and it's actually a little bit common for boron and aluminum to have less than an octet. That's a property very different from carbon, nitrogen, oxygen, and fluorine. Okay? But boron in particular is going to be able to violate its octet by having fewer electrons, but not more. Okay? In this case, boron, notice, only has 6 electrons. That's going to be 2 electrons from each of these bonds, totaling 6. That's okay, but it would be very bad if these fluorines or the boron exceeded their octet, having more than 8 electrons. But this is okay. So that's the first thing that I wanted to mention about this example. That's also something important to remember. The second thing is, let's suppose I had a weird case where maybe I counted 26 electrons, okay? Now that wouldn't be the case for this compound, but if you're adding up all the non-bonding electrons and you haven't hit your total yet, meaning you have to add more, there's a 5th step here where you'll actually add the remaining electrons usually onto the central atom. In the next example that we'll do in the next video, we'll actually see that where we'll actually have to add electrons or non-bonding electrons onto the central atom because the non-bonding electrons, when we add them onto the peripheral atoms, we're going to have extras left over. So make sure to join us in that video. But hopefully for this video, this gave you a good understanding of how to draw a Lewis structure given these general steps right here. Alright, please make sure to like this video and subscribe to my channel for future videos and notifications, and then in the next video we'll do that slightly more complicated example. Thank you.